Morning, everybody. Once again, Dr. Salim is here with you guys. Let's talk about a few more questions, which are similar to ARDMS questions. So these are just the review questions. Let's do our self-evaluation and see if we can practice some more questions, and we can make it easier, the SPI examination, to pass it on the first attempt. Let me share the screen with you guys. Be with me. Okay, so here is the question. Let's do this way. Okay, the question says, how much of the sound will reflected to transducer from the boundary of the second medium while both mediums have the same impedance? If their impedance are exactly the same, equal. So what do you think? Which one is the correct answer? 100%, 50%, 25%, none, or 75%? What do you think? Yes, I'm also agree with you. It's none, because if both mediums are matched, they have the same impedance, the same resistance. So the sound will just transmit, nothing will reflect back, right? Okay, let's do the next question. Easy question. Now, what would be the intensity reflection coefficient if the first medium had an impedance of 99 rails and the second medium had an impedance of 100 rails? Very simple, easy question. Pay attention. Minimum, maximum, no transmission at all, or 100% reflection? What do you think? The question is asking for reflection coefficient. Remember, read the question twice always. Remember that. Yes, this will be minimum. Why minimum reflection will happen? Because look, one is 99 rail and the other one is 100 rail. So they have just one rail difference between each other. It means the most of them, they are matched. So reflection happens when there is a mismatch, huge mismatch. Transmission happens when there is a mostly like maximum matching between the two mediums. So A is the correct answer. Let's do the next question. Okay, this question is asking that what would be the intensity reflection coefficient if the first medium has an impedance of 2 rails and the second medium had an impedance of 98 rails? So what do you think? How much the sound will reflect back? It's almost the same question, but with a little different concept. Minimum, maximum, no reflection at all, 2% reflection, none of the above. What do you think? Exactly. They will have a maximum reflection. Why? Because look, one is just 2 rails, the other one is 98 rails. So they have a difference of 96. They have rails difference between them. So there is a big mismatch between them. So maximum will reflect back. Next question. If we have an intensity of 100 milliwatt in a centimeter square, striking a boundary and completely reflected, what is the intensity transmission coefficient? A very simple, easy question. Just read the question twice. I will read it for you because it's a very simple question. If we have an intensity of 100 milliwatt in a centimeter square, striking the boundary and is completely reflected, what is the intensity transmission coefficient? What do you think? Exactly 0%, because everything is reflected back. There is nothing transmission, right? There is no transmission to the next medium. The question is telling you completely reflected, so 0%. Be careful with this type of questions. ARDMS may trick you with those questions, so be careful. Read the question always twice. Okay, this is a question about the law. Like, whose law is this? It says the degree of the refraction is directly dependent on the change and propagation speed as transmitted across the boundary of second different medium, according to whose law? Who says this? Is it Snell's law? Is it Bernoulli's law? Is it Newton's law? Is it Galileo's law? Or is it all of them? They says they agree with this. Yes, I agree. This is only Snell's law. Good job. Next question. What condition must be satisfied for the sound wave to be refracted? Like which conditions are important? Then when they happen, then we can see the refraction of the sound. Is it different propagation speed is important? Is it oblique angulation is important? Is it both of them are important or none of them? For the refraction, sound bending. Yes, both of them. if there are two different mediums who have different propagation speed, and also the angulation is not 90 degree, it's not perpendicular, it's oblique incidence. So that is important. It means C is the correct answer, both of them. Absolutely correct. Let's do this question. All right, it's a true and false question. With oblique incidence and propagation speed of the sound, medium 1 and medium 2 are equal, so angle of insonation, angle of reflection, angle of transmission, all are the same. Let me read the question one more time. The question is basically telling you that if the oblique incidence and propagation speed of the two medium are the same, they have the same propagation speed and their oblique angulation we do. So if the mediums are the same on that case, what is the, and also it is a smooth surface, completely smooth surface. So what this is, the angle of transmission, the angle of incident, the angle of reflection, three of them will be the same. Is it true or false? Exactly, it's true. Absolutely true. Okay, let's do the next question. This is a very easy question. If attenuation coefficient is 5 decibel in a centimeter for a transducer, calculate the operating frequency for this transducer. They just give you the attenuation coefficient and telling you, now you should know the formula for attenuation coefficient to answer this question. But anyway, let's see which one is the correct answer. What do you think? Exactly correct. That will be 10 megahertz. Why? Because for attenuation coefficient, we have a formula that it says attenuation coefficient is equal to operating frequency divided by 2. When we have half of operating frequency, that is actually the attenuation coefficient. So here it's already given to you. To make it back to the frequency, you have to multiply with 2 to get the operating frequency. So 5 times 2 is 10 megahertz. So D is the correct answer. Okay, let's do the next question. Now, the redirection of sound wave to many directions from the rough surface is called what? Is it a normal reflection? Is it called scattering? Is it called transmission? Is it called refraction? Or is it called reverberation? What do you think? When there's a rough area and the sound goes to all directions, what does it call? Yes, B is the correct answer. It's called scattering because sound go to all different directions. Because the irregular, that is a diffuse reflection also, you can say. Okay, let's do the next question. The question is asking, select the best example of relay scattering. Very good question. Always, all ARDMS SPI questions have this question. Always that exam, this question is there. So what do you think? Which one is the best example for relay scattering? Is it diaphragm? Is it bony surface? Is it red blood cells, RBC? Is it vessel walls? Or is it thyroid tissue? What do you think? Yes, it is C. It is RBC, red blood cells. That is the correct answer. Because red blood cells, the size of it is smaller than the wavelength. So it goes all direction. It's direct. The direction of RBC is from all directions, or we can say it is go to 160 degree. It goes to all 180 degrees. Sorry, it goes to all directions. Correct. Okay, let's do next. Okay, now if frequency get doubled, what happens to relay scatter? What do you think? Now again, you have to know the formula, because if you know the formula, the question is. But let's see. What do you think? Is it increased 16 times? Is it increased twice? Is it get half? Is it increased by 4 times? Is it increased by 32 times? What do you think? Which one is the correct answer? Yes, it will increase by 4 times. Because on the relay scatters, we said relay scattering frequency is at the power of 4. So you will get 4 times bigger. Correct. D is the correct answer. Let's do the next question. If a pulse spend 26 microseconds in a soft tissue and transmission phase, calculate the depth of the reflector. If sound go one way and spend 26 microseconds, where is the object? So the reflector is where? Is it 1 centimeter depth? Is it in a 2 centimeter depth, 3 centimeter, 4 centimeter, or 5? Again, there is a formula for this. But your answer is correct. It's a 2 centimeter because for each 13 microsecond, that's a 1 centimeter depth. Each 13 microsecond. Now 26 is like, 2 times 13, that's a 2 centimeter depth. Okay, good job. And the formula is, you can do that timing divided by 13. So if we do this time 26 divided by 13, that will give us 2 centimeter depth. Okay. Next question. If the pulse spins 78 microseconds in a soft tissue and a transmission phase only, like one way, calculate the depth of it. Same question. So what do you think? Now, 78 divided by 13. How much is that? I believe that will be 6 centimeter, right? You do it your calculation. So B is the correct answer. Now, let's do the next question. Is it that correct? 6 centimeter? Yeah, correct. Okay, next question, 174. So it says, if a pulse spins 130 microseconds in a soft tissue in a transmission phase, calculate the depth of the reflector in millimeters. Oh, that's like 2 questions. All right, let's see. 100 millimeter, 80 millimeter, 10 millimeter, 130 millimeter. What do you think? Which one is the correct answer? So the simple way is 130 divided by 13. And that will give us 10 centimeter, right? Now, each centimeter is equal to 10 millimeter. So 10 times 10, and that will be 100 millimeter. So 10 centimeter was the centimeter. Now to convert it to the millimeter, so we have to times with 10, another 10, right? Because each centimeter is equal to 10 millimeter. And that will be the correct answer. Good job. Let's do the next question. If a pulse spans 52 microseconds in a soft tissue and transmission phase, calculate the depth of the reflector in millimeters. So what do you think? Same questions, just they're asking in the millimeter. Again, 52 divided by 13. And I believe 52 divided by 13 will be 4 centimeter. So now 4 times 10 to get millimeter. And that will be 40 millimeter. That's the correct answer. Okay, nice. Let's do the next question. Okay, now it says, if the depth of a reflector is measured as 40 millimeter, calculate the pulse transmission time. So here they are asking for different thing. Before, other question just we did previously, they were asking for the depth. Now they give you the depth and tell you how much time was spent by the pulse. So 40 millimeter, first of all, we have to convert this to centimeter. So 40 millimeter, if you make it divided by 10, that will give you centimeter. So 40 divided by 10 is 4. So 4 centimeter, we can say. Now, to calculate, to get the time, what you do, this time, this depth times 13 microseconds. So 4 times 13, I believe that will be 52 microseconds. C is the correct answer. Very good. Let's do the next one. Okay, now, if the depth of a reflector is measured as 6 centimeter, calculate the pulse transmission time one way. When I say transmission time, just carefully read the question, okay? If they ask you this question differently, if they tell you what is the total distance traveled by the pulse, then you have to make it both way, one way and another way. So in that case, then you will be able to find both ways. How much distance was traveled or how much time for both going and coming of the flight was spent. But here they're asking only for one way, transmission time only. So 6 centimeter depth. Yes, if you do 6 times 13, so how much will be that? Exactly. I think that would be 78 microsecond. I think if you have doubt, calculate it. So 6 times 13. Okay, I believe that will be 78. That is the correct answer. Now, let's do the next question. It says, if the depth of a reflector is measured as 60 millimeter, calculate the transmission time. So exactly the same question like above question we had it here. This question, both. These two questions are exactly copy-paste of each other. Only the difference here it is 6 centimeter and here it says 60 millimeter. So 6 centimeter and 60 millimeter are exactly the same thing. One is the unit millimeter, the other one is centimeter. So Same answer we will have. C here 78 microsecond. Here it was also A answer was correct. Here the C is the correct. Same. No difference at all. It's just the units are different. Let's do this question. From the interference of two waves that are out of phase and have the same amplitudes, what do you think? What will be the result? Because it's a interference artifact. We know speckle artifact. So now, if both ways, one go this way, the other one, so they are not in an end phase. They are out of phase. One is compression, the other one is rarefaction going on. So what do you think? Which one will be the correct answer if they have the same amplitude? For example, one wave is coming in the rarefaction area, the other wave exactly at the same location, the other one have compression, but their amplitude from baseline is exactly equal. Now I made it very easy for you. What do you think? Will be a stronger amplitude will be made because of this result? Will be weaker amplitude make because of these two out of phase waves? Is it smaller amplitude? It's no amplitude at all, or none of the above? What do you think? Exactly. D is the correct answer. No amplitude, because this and this one wave have a compression on the same location, same timing. The other one is exactly going on is the rarefaction, another wave, and they have the same amplitude. They will cancel each other. It will be just a baseline. No amplitude would made. Correct answer. Okay. Last question, but not least. Let's do this question. From the interference of two waves that are in phase. The above question was out of phase. Now it's in phase. Okay, what will be the result? If there are two waves and they are in phase, two waves are coming together on the same timing. The compression of one wave and also the other one also have the compression on that location. The rarefaction of the second one, the same, the first one and the second one have the rarefaction. So their compressions are matched on the same location, same place, and rarefaction are on the same. So what do you think? What will happen to the cycle of this amplitude? What will the result will be? Stronger amplitude, weaker amplitude, smaller amplitude, no amplitude, or none of the, or all of the above? What do you think? Exactly, they will produce a stronger amplitude because they will support each other because they're in phase, they're not out phase. So that will become a very stronger amplitude and your image will get a lot better image quality. Okay, I think this much is enough for today. So once again, my dear viewers, my dear friends, please do not forget to share this link of the YouTube channel to all those healthcare providers or all those who want to sit for the ARDMS examination, or they want to know ultrasonic physics in depth with detail, with the mechanism. So please tell them to subscribe the channel as well. And please wait for the upcoming notifications. And then we will keep this until you pass your examination. Thanks a lot and take care.